One of the basic drives of mankind has been to adapt his environment to himself. His needs are best served when he has a familiarity with and knowledge of that environment. With the opening of the vertical frontiers of space, man now stands at the threshold of new techniques of navigation, communication, and aerology never before visualized or thought possible. To be perfectly familiar with this special environment, man must inevitably follow his machines into space. He must see and know. The equipments of scientific investigation to make this space exploration fruitful are available now. The big problem is attainment of safety and reliability. These goals can be reached only by the most meticulous instrumental investigation of the infinity into which mankind plans to project himself, in order to perfect an environment into which the astronaut can safely come and go at will. An essential contribution to this effort was the successful launching and recovery of the initial nuclear emulsion recovery vehicle at Point Arguello, California. The NERV investigation was designed to obtain a detailed record of the inner zone of the radiation regions surrounding the Earth and return the recorded information for study. Based on the company's substantial reputation in the field of space probes and sounding rockets, the National Aeronautics and Space Administration assigned the task of putting the payload into space and getting it back to the Aerolab Development Company of Pasadena. One of the principal tasks of this Ryan Aeronautical Company subsidiary was the fabrication of the assembly hardware for the Argo D-8 vehicle, one of a family of low-cost, high-performance sounding rockets of proven dependability. Precision tolerances were required in order that errors in predicting the flight path of this unguided ballistic rocket would be at an irreducible minimum. Further assignment was for the calculation of the trajectory and dispersion caused by all of the tolerances in the system. Everything hinged on the success of this phase of operation, since recovery of the payload was vital to the investigation. Trajectory and dispersion computations were accomplished using the most sophisticated techniques available. All computations were made using both a 6-degree freedom program, including wind effects, as well as a 2-degree freedom program for that portion of the trajectory outside the sensible atmosphere. The vehicle was composed of a first-stage sergeant assisted by 2 recruit rockets. Lance rockets comprised the second and third stages, topped by a 4th-stage X-248 rocket. The vehicle, including payload, was approximately 62 feet long and weighed over 13,000 pounds. On the first 3 stages, the fins were slightly canted, causing spin and establishing spin stabilization for the 4th stage and payload. 4th stage burnout velocity was over 12,000 miles per hour at an altitude of 124 miles, occurring 95 seconds after liftoff. The NERV 83-pound payload, designed and built by the Missile and Space Vehicle Department of General Electric, had 2 important assignments. Of prime importance was the study of the interaction of the Van Allen radiation regions with the Earth's atmosphere and magnetic fields. Since the radiation belts continually change and fluctuate, it is important to future manned spaceflight to map the regions in detail in order that adequate minimum weight shielding can be designed for manned flight through the regions. A stack of 25 nuclear emulsions were exposed to radiation from about 300 miles altitude through apogee and back down to about 600 miles. Nuclear emulsions recorded the passage of any charged particle having sufficient velocity, 5 million electron volts or more, to penetrate the emulsion. 3 packages of mold spores were carried in an area of the vehicle unprotected against radiation. These spores will be studied for mutations due to their exposure to a known radiation field. Countdown zeroed at 8:35 a.m., September 19th, 1960.
25, 20, 19, 18, 17, 16, 15, 14, 13, 12, 11, 10, 9er, 8, 7, 6, 5, 4, 3, 2, 1, mark.
The Argo D-8, launched from the Naval Missile Facility at Point Arguello, California, flashed past 4 new milestones in the United States space effort. First, Argo D-8 flight test, completely successful. Highest altitude of any recovered payload so far. First West Coast National Aeronautics and Space Administration launch, and the deepest space penetration with living organisms aboard, 1,200 miles. Previous record, 360 miles. The trajectory calculations were a huge success. Impact was at 10:17 a.m. in the bullseye area. All units functioned perfectly. Processing of all the data accumulated will occupy the coming months. In Project NERV, theory has become fully successful hardware. Hardware in operation has proved theory. Other Aerolab operations in space exploration will add other facts to proven knowledge of a new environment, adding further paragraphs, further chapters to the story of man's conquest of space.